Hello everyone, Nick here. Welcome to our Project 4 for Physical Computing. Today I'm going to be demoing our reaction and movement time test. So here on our physical build, we have an ESP32 in a simple circuit, including a push button, and this will connect to our phone using BLE. So to begin the test, from the phone side, we press scan and connect, which will connect it to the ESP32. We then push down the push button, which will make it armed. After a short moment, a button will appear digitally on the phone. Once pressed, we see two values, our reaction and our movement. So our reaction value was the time it took to release the push button once we seen the digital button. And for our movement value, that's the time it took to press the digital button. All right, and for the code walk, I'll be handing it over to Neil.
Hello everyone, this is Neil and I'll be explaining the code for our Project 4 time reaction test for physical computing. Starting off with our Arduino code here on our preamble, we have our libraries, our variables for our button, as well as our BLE UIDs, some variables to help us for the notifications and writes to the phone, a boolean variable to check for connection, some variables to help with the calculation for the reaction time later on, and as well as some helper functions. These essentially just format the strings that we send to the phone so that the phone can read it and parse it and get whatever it needs from there. Here's our callback. So we have our connection callback. So this checks if the phone is connected or if the device is connected. If true, then we don't do anything. If false, then we restart the advertising so that the phone can scan for it. Here's a callback for our reset and queue. So on our phone, we have reset and queue buttons. So whenever each of those are pressed, for example, the reset, it'll set the queue time and release time to 0. And whenever the queue shows up on screen, and the phone will send us a notification to the ESP32, and then we'll record what time that was activated in milliseconds, as well as some error handling here at the bottom. Alright, moving on to our setup. Here we just have our pin modes for our button and all our BLE stuff right here. So this is just our BLE server and creation, as well as some of our event notification stuff. Here we start the service and then we start advertising the service as well. And I just have a little serial print here to help me know that the code is working. Alright, so finally on our main loop, we have a debounce handling again for the button to help filter out some of the electrical noise. The most important thing here is the booleans that we have for the button to let us know if it's pressed or released. This gives us our release time, which we'll then use to calculate the reaction time based on the release time and the queue time. And then we'll send that reaction as a string as well to the phone. Alright, then moving on to our phone code, we'll start with our BLE manager here. So this is our BLE manager class. Over here you can see we have variables for our UIDs, just so we can match what we scan with the phone. Some variables for our scanners, our adapters, our GATs, and some of our listeners as well. Here we have our constructor. So this gives context to our scanners and adapters and basically initializes them. And here's a bulk of our callback codes. So for this first one, it essentially just, if connected, it requests a larger MTU so we can fit all of the JavaScript object notation objects that we receive from the ESP32 in one packet. And if it's disconnected, then it just sets our status to disconnected and then helps reset the UI later on as well. Some MTU resolver stuff there, just helps with the MTU that we receives. On services discovered, so this essentially just finds our service that we're advertising. It also resolves events like the notification and write characteristics. And it enables the CCCD as well. Alright, and And here on characteristics changed. So essentially for this one, it just this receives the notification chunks that we get from the ESP32 and reassembles them into complete objects that we will forward to the listener. And here's some of our event handlers. This one just passes the raw event up to the on event method that we'll see later on. And as far as a parsing method as well here, just so we get what we need to from the string. Essentially looks for stuff like milliseconds, reaction, RT, stuff like that. And then it parses that from the string and then helps us process it in our code. Here's our start and scan connect. So this is what starts our scan for our phone. Most importantly, we always ask for permission. I also have some location permission here. We don't really need that, but the most important part is that we ask for the Bluetooth permissions. And once we have those, and these are all still just scan as well, yeah. And on result, this lets us know the result of our scan. And stop scan, send and close. All right. So let's go ahead and move on to our primary Java code, our main activity code. Again, here at the start, we just have a bunch of variables, stuff like for our BLE managers, for our constructors on the BLE manager, and our text views, as well as our buttons and layout stuff that I'll be showing on the XML code later on. Some connection booleans and ARM booleans for the physical button. This becomes true whenever the code is ready to, or the physical button is pressed, as well as some variables for our Q button that will appear on the screen. As you saw in the physical demonstration, a flashing button will appear. Alright, so here on our onCreate method, this is where we bind our layout stuff, as well as our helper classes to the backend. So this binds stuff like our text, our statuses, our buttons to the layout code. Here we just have a bunch of code for the flashing Q. We're setting it at a random placement from anywhere within the bounds. And here's where we get or record the movement time and compute the movement time as well. And here is our scan connection. So yeah, that just starts scanning. That's for a scan button. So it first makes sure that we have permissions. If we do have permission, then it starts the start scan and connect method that we saw earlier. If not, then it returns. Here's our code for the reset button. As you saw earlier on the Arduino, it's constantly listening for the reset command to reset the reaction and queue times that it has on there, on its memory. Here we initialize our UI, so we set all the values to null, so it doesn't have anything there, and we'll write to it later on. Sets our status and the instruction stuff as well. And our on destroy, this is just when we close the app. So I have a bunch of permission stuff here. This essentially just makes sure that I have permission from the phone. Yeah, and then like it does the same thing as the scan, but I put it there because I run into an error earlier. Alright, so our status, our connected method, this essentially sets our connection for the queue right there. And our on event, so this handles all of the strings that we receive from the ESP32. Like the button is held, the button was released too early, and the reaction time that we get from the ESP32 as well. Oh, and I forgot to mention, the unconnected also tracks the connection state. So once it disconnects, it cleans up the UI. Alright, moving down on reaction time, this is where we set our reaction on the screen that we bind with the view bind earlier. This is the queue logic, so our queue is scheduled to appear at a random time between 1 and 5 seconds, and while it's doing that, we make sure to let the participant know that the trial is armed, or the test is armed. Alright, and then we also mark whenever the queue time is shows up, and that's when we send the ESP32 to let it know that the queue has shown up as well. I just have a little cancel here just in case. Here it shows the this is where we get the location for the queue button. So it shows up, the queue button shows up at a random location within the boundaries that we set. And this is what places the queue. Here we hide the queue whenever the button is pressed. This is code for the flash, to make the button flash, just so it's a little easier to notice, I suppose. And more of the queue stuff. Here we have our parsing helpers. Again, we check for stuff like from the string that we're receiving from the ESP32. We check for stuff like milliseconds, reaction time, events, stuff like the reaction. This helps us kind of get what we need from the string, so we can process it in our code. And here I just have a bunch of UI helpers at the end as well. Alright, so these just kind of set the text that you will see on the screen. Alright, so going over to our layout files. So this is what governs all of our UI, or what we see in the UI essentially. Here we have our app title, as the name suggests, it's the title of our app right here. We have our status text, that's a status that appears down here, which is updated on our backend. Our metrics, so that's the reaction and movement time. So the layout file is essentially just the format of the UI that we have. And I believe we should have, so we have static and dynamic steps. So our static steps are here. It explains how to use the code or the test, and then a dynamic step right here to kind of let the user know what he or she should be doing right now. And oh, there it is. So here's our queue playground and our queue button code. You're not able to see it right now, but it will show up as you saw on the physical test. And then our control buttons are scan and connect and then reset buttons as well. Alright, that's it for the code. Thank you for watching.